This is linear algebra. We're gonna discuss orthogonal projection. What is gonna be orthogonal projection? Here is vector is y. They give the y vector, and then they give another vector is here w vector space. Then this vector is have sum of two orthogonal vector. One is y hat. We call orthogonal projection of y. The other is z vector. Z vector is orthogonal to the y hat vector. So how gonna we find the two orthogonal vector? Here is you're gonna find it. One is y hat projection on L of y. You're gonna find this scalar value times u vector, and the z vector is y minus y hat vector. So I give the example. When you give the y vector, we're gonna find two orthogonal vector. Sum of two orthogonal vector gonna be y. How can find the projection of y onto the u vector? So they give the u vector is right there. So here is a y vector. We on the all the line is the span of u vector. So we have to find this length. So y hat gonna be projection of y onto the u vector gonna be scalar value is right there. How can find it? Y inner product u, u inner product u, and u vector. That's you're gonna find projection of y. So let's calculate this one. That's the 28 plus 12 over 16 over 4. That's the u vector. You find the scalar value. That's the 40 over 20 u vector. That's going to be 2u. Twice longer than original u vector. So what is y hat orthogonal projection vector going to be? 2 times u. So 2 times u vector. 4 and 2. That's going to be 8 and 4. So when you find the projection vector of u, y, then we're going to find the z vector. Z vector is orthogonal vector to the projection vector. That's going to be y minus y hat. So y minus y hat, that's going to be 7, 6 minus 8, 4. It's going to be negative 1 and 2. That's going to be z vector is orthogonal to the orthogonal project vector. Then y gonna be, you see, here is y gonna be y hat orthogonal projection vector plus z. Relation between y hat z is orthogonal. Let's prove that one here. So y vector is y hat vector gonna be 8 and 4, and z vector gonna be negative 1 and 2. That's the orthogonal or not. We're gonna check inner product. That's the 8 times negative 1 plus 4 times 2 is 0. That's orthogonal. Then y is a sum of two vectors. So y vector is 7 and 6. The y hat vector gonna be 8 and 4. Z vector gonna be 4 and 2. Z vector gonna be negative 1 and, negative 1 and 2. Okay, that's how to find the two vector. Let's practice this example. So we want to find two orthogonal vectors whose sum is y vector when you given the u vector. So idea is y vector is right there. That's y vector. Here's a u vector. Then you're gonna find the projection of y onto the u vector. That's gonna be y hat. Then you're gonna find the z vector. That's the orthogonal vector. So when you're using the theorem, very simply, we're gonna see y hat vector gonna be scalar value y times u inner product u, and the u vector. That's the component of projection vector, and the z vector gonna be orthogonal to the y hat vector gonna be y minus y hat. That's you're gonna find it. Let's find it. So this one is inner product y and u. That's the 8 minus 21, and inner product 2u vector. That's the 16 plus 49. Let's find the component first, guys. Then what is this value gonna be? This one is negative 13 over 65 u vector. That's gonna be negative 1 over 5. U vector is 4 and negative 7. This one gonna be negative 4 over 5, 7 over 5. That's why projection vector of y onto the u vector. How about z vector? Z vector gonna be orthogonal to the projection vector. That's gonna be y minus y hat. You're gonna find the y is 2, 3, y hat is negative 4 over 5, 7 over 5. So you have 2 minus 4 over 5. Here it is 3 minus 7 over 5. So you're gonna find that this one is 14 over 5. This one gonna be negative 8 over 5. So you find the two vector whose sum is y vector. So y vector gonna be y hat projection vector of y plus z vector. So you can see obviously y hat vector gonna be negative 4 over 5, 7 over 5 plus z vector gonna be 14 over 5, negative 8 over 5.